Physics in Brief presents JEE Crash Course 2018. This is the second module of this course. In this module, we will discuss about the units, dimensions, and errors involved in physical measurements. Lesson number 1, Units and Dimensions. All measurable physical quantities can be divided into two groups, number 1 primary, or fundamental quantities, and number 2, secondary, or derived, quantities. Fundamental quantities. Small group of quantities, from which all other quantities can be formed, is known as fundamental or primary quantities. Examples: mass, length, time, electric current, temperature, luminous intensity and amount of substance. Note that electric current is a fundamental quantity, and electric charge is a derived quantity, although electric charge is fundamental, and electric current is the rate of flow of charge. Derived quantities. These quantities are formed from primary quantities. Those units, which are obtained from the fundamental units, are called derived units. Example: the unit of speed is meters per second, which is a derived unit, where m and s are the fundamental units. Dimensions. Dimensions of a derived unit are the powers to which the fundamental units of mass, length, time must be raised to represent that unit. For example, speed is equal to distance by time. That is, it has dimensions of length per unit time. So, speed is said to possess 0 dimension in mass, 1 dimension in length and -1 dimension in time. Dimensional formula. Dimensional formula is an expression which shows how and which of the fundamental units are required to represent the unit of a physical quantity. For example, m to the power 0, L, t to the power -1, has the dimensional formula of speed. Dimensional equation. Dimensional equation is the equation obtained by equating the physical quantity with its dimensional formula. For example, speed is equal to m to the power 0, L, t to the power -1, is the dimensional equation of speed. There are 4 categories of physical quantities. Number 1, dimensional constants, which have dimensions and a fixed value. Example: gravitational constant, Planck's constant. Number 2, dimensional variables, which have dimensions, but don't have a fixed value. Example: velocity, force. Number 3, dimensionless constants, which don't have dimensions, but have a fixed value. Example: numerical constants, by E, refractive index. Number 4, dimensionless variable, which neither have dimensions nor have a fixed value. Example: strain, specific gravity. Principle of homogeneity of dimensions. It states that a given physical relation is dimensionally correct if the dimensions of the various terms on either side of the relation are the same. This principle is based on the fact that two quantities of the same nature only can be added up. The resulting quantity is also of the same nature. Uses of dimensional equations. Dimensional equation can be used to convert a physical quantity from one system of units to another. Check the dimensional correctness of a given physical relation. Establish a relation between different physical quantities. Thank you. Visit physicsinbrief.com for assignments, mock tests and more courses.